Okay guys, why don't you go ahead and try the warm-up, and then when you're done, resume to see if you got it correct. It says the value of the expression negative absolute value of a minus b, when a is equal to 7 and b is equal to negative 3 is which one of the following. So we're going to go ahead and do a basic substitution. We're going to substitute 7, whoops, hold on.
DJ Nocella, dial 1104, please. DJ Nocella, dial 1104.
7 minus, and the b is a negative 3. Be careful with that because we have a negative negative. So that gives us plus, and 7 plus 3 is 10. The absolute value of 10 is 10, and that negative is brought over. So the answer is choice 1. Be careful. This right here is the trick answer. A lot of kids see absolute value, and as soon as they see it, they think no matter what, the answer is going to be a positive 10. However, if the negative is on the outside of the bars, the absolute value does not affect it. All right, multiplying and factoring. Let's not forget the distributive property, which you learned back in middle school. The distributive property is literally distributing the number on the outside that's multiplied through. You're multiplying a monomial of 3 by a binomial of x plus 2. So you have to multiply each of these. 3 times x is 3x, and 3 times 2 is 6. This is called the distributive property. Remember, when you multiply variables the same base, this is what we learned in our last chapter with exponents, then you're going to add the exponents when you're multiplying same base. Okay? So 4x times 2x is 4 times 2 is 8, and x to the first times x to the first is x to the 1 plus 1 is 2. Okay, so keep that in mind as we go through some of these problems, because we're going to end up multiplying variables when we use the distributive property. No matter how many terms you are multiplying, the distributive property will work. So if you look at this example, you may not have seen this in middle school, but we're now multiplying a monomial by a trinomial. It's got 3 terms. You're still going to go ahead and multiply 5n times the first term, 5n times the second term, and 5n by the third term. Remember, when you multiply, you're going to add exponents of the common bases. So 5n to the first times 3n to the third would be 15. N to the first times n to the third, adding the exponents would be n to the fourth. Now take the 5n and multiply it by the negative 1n squared. 5 times negative 1 is negative 5. N to the first times n to the second is n to the third. Now multiply your 5n to the first times 8. 5n times 8 is 40. So 5n times 8 is 40n. Are there any like terms in this trinomial? No. Even though they all have bases of n, none of the exponents are the same. Therefore, you cannot add any of them because none of them are like. Factoring out the GCF. Remember, what you have learned a few years back, that GCF stands for greatest common factor. The opposite of distributive property is called factoring. This is a really important comment here. The opposite of distributive property, which is what you've been doing for a couple years, if you do the opposite of that, you're actually doing a factoring. And we're going to factor out, you're going to learn how to factor out the GCF. Okay, so we're going to look for the greatest common factor to take out. You're going to pull it out on the outside of the parentheses and then figure out what the GCF could be multiplied by to get back to the original. Make sure that you're pulling out the greatest common factor, not just any common factor. All right, so make sure you copy this down and then put me on pause and proceed on, so I'm not going too fast. Here are the example. Here's one example. It's a trinomial. It says, that's actually a typo in there when I took the snapshot. Let me get rid of that. It's not really there. We have 3x to the fourth minus 9x squared minus 12x. First thing you guys want to do is look at the coefficients only. The 3, the 9, and the 12. Is there any number, the largest number, because we're looking for the greatest, largest number that will go into 3, 9, and 12 evenly. 3. 3 is all three of these coefficients are divisible by 3. Once you get out the GCF of the coefficients, then look at your variables. All of them have x's in it. The first one has 4 of them, the second one has 2 of them, and the third one only has 1. So what's the most number of x's you can take out of all of them? I can take out up to 4 here, up to 2 here, and only 1 here. So if they're asking you to take the most out of all of them, the most you can take out would be 1, because the last term only has 1 to offer. Okay, so therefore the GCF is equal to 3x. Once you figure out what the GCF is, then we're going to factor it out by doing the opposite of the distributive property. So think about the opposite. You're going to open up your set of parentheses and you're going to think 3x times what gets me back to the first term of 3x to the fourth. Well, 3 times 1, I don't need to write it, it's imaginary, and x to the first times how many more do I need to get x to the fourth? That would be x to the third. So if you multiplied this, 3x to the first times 1x to the third, you would end up with 3x to the fourth. Drop down your minus sign. 3x times what will give me the second term of 9x squared? Well, 3 times 3 gives me my 9, and x times x will give me x squared. Drop down the minus. 3x times what will give me the third term? 3 times 4 gives me my 12, and x times 1 gives me my x, so you don't need to write that. So let's go ahead and do a double check in our head and make sure that we did this correctly. And how do I do that? I just go ahead and do distributive property. So let me go ahead and get rid of these. And we end up with 3x times x to the third would be 3x to the fourth. Good. 3x times negative 3x would be negative 9x squared. Good. And 3x times negative 4 gives me negative 12. So I just factored out the GCF. So when they tell you to factor, you look for a GCF first. Some of them will have it, some of them will not. And if they do, factor it out by doing what we just did, which is the opposite of the distributive property. All right, let's look at a helipad. A helipad is where it's a pad where the helicopter, actually, it's the landing base for a helicopter. If you look at this picture, we're talking about a square. And the square is 2x by 2x. And the radius of the circle within that square is x. They want me to find the shaded region of the area of the helipad. Okay, so now the shaded region is what you see in red, those little triangular corners. So really what you want to do is you want to find the area of the square, which is the bigger shape. So we want to find the area of the square. Then we want to find the area of the circle, which is within the square, the smaller shape inside. And then to find the area of the shaded region, you would literally cut the circle out of the square, which means you would subtract. Take the bigger shape, subtract the smaller shape. So the area of a square is side times side, so it's 2x times 2x. And 2x times 2x is equal to 4x squared. So that's the area of the square. The area of the circle, you should know the formula of a circle from back in middle school, which is pi r squared. We're going to leave it in terms of pi, so don't put in 3.14, leave that alone. And the radius is x squared, which is equal to pi x squared. So here is the area of the square. It's a little dark. Here's the area of the square. Here's the area of the circle. In order to find the area of the shaded region, we're going to take the square and subtract the circle. We're going to take the big shape and subtract the small shape. When you go ahead and subtract those, this is one way to leave the answer. The other way to leave the answer is to think about taking out the GCF. And both of these terms have an x squared in common. So we're going to take out the x squared from both. X squared times what gives me the first term? 4. Minus x squared times what gives me the second term? Pi. So that's the answer of the area of the shaded region in factored form. Okay, so that's pretty much it. That's 8.2. Go ahead and look that back through if I went too fast, and I'll see you guys at class. Thank you.